Before we actually jump into the code, let's walk through a visualization of what an example looks like. So here we're given a list of valid coins we can use, and we're also given the target amount that we want to create. And what we need to do is create a DP array where each element corresponds to the minimum number of coins needed in order to create that amount. So for example, DP4 would be the number of coins needed minimum in order to create 4 cents. So I've initialized the array to be 0 in the 0th index and to hold the value of amount plus 1 in all of the other indices. And that's because when we're iterating through the array, we'll be picking the minimum value. So we'll be replacing amount plus 1, which is an invalid value, because we'll never need more than amount number of coins in order to make amount. So for example, we'll never need more than 4 coins in order to make 4 cents because the minimum is 1. For each index starting from index 1, we'll iterate through the coins list and ask ourselves if I, which is the index number, is greater than or equal to coins j. So for example, when I is 1 greater than or equal to coins j, which is 1? And because the answer is yes, that means we can go back 1 step and see the solution of dp0 is 0. So we add 1 to whatever previous dp we land on. So 1 plus 0 is 1. And because 1 is smaller than 5, we always want to fill this cell with the minimum possible combination. So here is we replace 5 with 1. Then we continue down the coins list. So is 1 greater than or equal to 2? And the answer is no. So that means we move on, and the minimum number of coins needed to make 1 cent is 1 coin. So then we go to 2, and we ask the same question: is 2 greater than or equal to 1? And because it is, we can go back 1 step and see the solution to dp1 is 1. And so we do 1 plus 1, which is 2. And then we ask, is 2 greater than or equal to 2? And the answer is yes. So we can go back 2 indices and see that the solution of dp0 is 0. And so 0 plus 1 is 1, which is less than 2. So because we always want to take the minimum combination, we replace that with 1. Moving on to 3. So we see that for 3, well, 3 is greater than or equal to 1. So that means we can go back 1. And dp of 2 is 1, so 1 plus 1 is 2. But do we have any better options? Is 3 greater than or equal to 2? The answer is yes, so we can go back 2. We see dp of 2 is 1, so we do 1 plus 1 is equal to 2, which is what we already have here. And is 3 greater than or equal to 5? Well, the answer is no, so we can't do anything there. We move on to 4. So for 4, we ask the exact same question, iterating through coins. So is 4 greater than or equal to 1? The answer is yes, so we go back 1. So we get 2 plus 1 is 3. 4 greater than or equal to 2? It is, so we can go back 2, and we see that dp2 is 1, so 1 plus 1 is equal to 2, so we can replace that. And then is 4 greater than or equal to 5? The answer is no, so our optimal solution is 2. And we can check the logic there because 2 cents plus 2 cents gives us 4. So that's a total of 2 coins in order to make 4. And so that means we can return our final answer, which will actually be the amount index of dp. So that would be dp amount, which is equal to dp4, which is 2. Let's now walk through the solution in code. And here I've already outlined the general structure of the code. So if you want to pause, try it out yourself, you can do so now. All right, so first we initiate the int array dp, which will hold each element up to amount, and we add 1 to account for 0, so the 0th index. So for each element in the dp array, starting from I equal to 1, we iterate through filling in each element. So first we set dp of I equal to amount plus 1, as we did before in the example. So now for each element, we go through the coins list. And we ask whether I is greater than or equal to coins j. And if it is, we can then set dpi to the minimum of what the current dpi is, and the dp at index I minus coins j plus 1. And then after we've gone through all that, we will have filled in the DP array so we can return. Well, first we have to account for whether DP of amount is equal to amount plus 1, meaning that we weren't able to find any combination of coins to satisfy the amount that we want. And if that is the case, then we return -1 as directed in the prompt. Else we return DP of amount as seen in the example. All right, so let's submit. And there we go.